recording this video to give you some practice on the material that's going to be in the real test. So it's a mock test where we have to learn the basics of molarity, detecting combustion analysis, how to find the empirical formula based on the data, on the percent composition data, and how to find the formula based on the, again, percent composition data. So in the first question, we're asked to find the molar mass of aluminum sulfide. Aluminum sulfide is composed of aluminum with a charge of +3 and sulfide, which is a charge of -2. When you combine them, one of the tricks they recommend is you do a crisscross. So the 2 aluminums and 3 sulfur atoms will create an ionic substance that has no charges. So aluminum sulfide is Al2S3. To find its molar mass, 2 times the molar mass of aluminum, 3 times the mass of sulfur gives you a total of 150.1608. You're only allowed 5 significant figures because sulfur is reported to only 5 significant figures of accuracy, so the final answer has to be 150.16. All these red arrows point out what I'm looking for when I correct this particular problem. So I'm looking for the aluminum with 2, the sulfur with 3, that there's 2 times the molar mass of aluminum, that there be 3 times the mass of sulfur, and that the total is 150.161, and then that you report it to the correct number of significant figures. So number 1A is 8 marks. The second question is to find the percent composition, the percent oxygen in chromium nitrate. Chromium nitrate, it's chromic nitrate, so chromic has a +3 charge, nitrate is -1, so you need to bracket the nitrate and put a 3 around it because that's what's going to give it a charge balance. So the chromium weighs 51.996, the nitrogen weighs 14.0067, there's 3 nitrogens, that 3 signifies that there's 3 nitrates. So that means 3 nitrogens and 3 times 3 oxygens, or 9 oxygens times the molar mass of oxygen, which is 15.394. Total mass is 238.0107. You're not going to round it off yet because we're not finished the calculation. Percent oxygen is 9 times the molar mass of oxygen divided the molar mass of the whole substance times 100. It gives you a value of 60.4992129. Based on the significant figures that we have here, we're only allowed to report the value. The most accurate number we can report it to is 5 significant figures because chromium is only reported to 5 significant figures. So it's 60.499% oxygen. In this question, we're asked to find out the percent composition, the percent platinum in a drug called cisplatin, which is used to treat cancer. It's an anti-cancer drug. It binds to the DNA and it, I guess it causes the polymerase enzyme to trip or skip or damage the translation, so it ends up killing the cell in the long run. So we have the molar mass of platinum, 2 times the molar mass of chlorine, twice the molar mass of nitrogen, 6 times the mass of hydrogen. You'll notice that the 2 outside of the bracket signifies that you get 2 nitrogens and 6 hydrogens because it's 2 NH3 groups. The molar mass of cisplatin is 300.04644. Percent platinum is 195.08 divided by the molar mass of the entire compound times 100, so it's 65.017% platinum. In question D, we're asked to find how many grams of barium iodide are found in 1.906 times 10 to the -2 moles of barium iodide. So we first find the molar mass of barium iodide, which is listed here. It's 391 grams per mole. Remember to put a 2 next to iodine. I think I gave the formula in the question as well. Yeah, it was already given. Anyway, barium is +2, iodine is -1, so you need 2 iodines to combine with the barium. Molar mass is 137 for the barium, 2 times 126 for the iodine, times the number of moles. You see how the units here give it away. The molar mass is grams per mole, and the number of moles is here. So moles cancel, your answer will have to be in grams. And that's what we're looking for, the number of grams in 1.906 times 10 to the -2 moles of barium iodide. So you're only allowed got 4 significant figures, so it's 7.455 that we reported to. That's where we get the number of significant figures. There are only 4 significant figures in the question, so that's the highest level of accuracy we can report it to. I would look for, you see where all the red arrows are, so this question is at a 7. You notice I always attribute 1 mark for significant figures. You will need to learn that in university. You might as well start now. The second question asks you to determine the empirical formula of a substance with 62.1% carbon, 5.21% hydrogen, 12.1% nitrogen, and 20.7% oxygen. So the first step is to assume that we have 100 grams of the substance, which is what we do, and that converts all the percentages into gram amounts, 62.1 grams of carbon, etc. Divide by the molar mass of each substance, and it gives you these mole ratios. Now we take the smallest number in the group, which is 0.86, and divide all of them by that 0.86, and it gives you 6, 6, 1, and 1.5. Almost all of them are integer values. The only one that's not an integer is the 1.5 here, representing the number of moles of oxygen. And since you obviously cannot have 1.5 molecules within 1.5 atoms within a molecule, it makes sense to double the values so that you get 12, 12, 2, and 3. So the empirical formula of this substance would be carbon 12, C12, H12, N2O3. I gave a mark for each one of these steps, and because there's 4 of them, you get 12 marks just for getting this right. So you never give up in the question. Always write anything that you can write that makes any sense at all, and I'll give you part marks for it. You'll notice the answer is only worth 1 mark. So the process is what I'm looking for. I'm looking to see that you understand what you're doing. In part B of number 2, the question is, what is the empirical and molecular formula of styrene, which contains 92.3% carbon and 7.7% hydrogen, and has a molar mass of 104 grams per mole? 92.3 grams of carbon, 7.7 grams of hydrogen. Divide by the molar mass of carbon, divide by the molar mass of hydrogen. Here's the mole ratios you get. You see they're almost similar. When I divide by the lower number, which is this one, they're both very close to 1. So we're told that as a result, we realize that the empirical formula is C1H1. When we calculate the empirical formula weight, we get that 12 plus 1 gives you 13, but the molar mass we're told is 104. So when you divide the formula weight by the empirical formula weight, you get a number very close to 8, which within experimental error should indicate to us that it is in fact 8. So 8 times the empirical formula will give you C8H8. And as it turns out, this is the formula for styrene. It's a benzene ring attached to a ethyl. And you see that has 8 hydrogens and 8 carbons. Third question asks, the fermentation of glucose, C6H12O6, produces ethyl alcohol, C2H5OH, and carbon dioxide. A asks, how many moles of carbon dioxide are produced when 0.4 moles of glucose reacts? So 0.4 moles of glucose reacts to form how many moles of carbon dioxide? Well, the stoichiometry is 1 to 2. So for every 1 mole of glucose, you're going to get 2 moles of CO2. But we have 0.4 moles of glucose, multiplied by 2, you get 0.8 moles of CO2. That's worth 4 marks. In question B, they're asked, how many grams of glucose are needed to form 7.5 grams of ethyl alcohol? Grams of ethyl alcohol, 2 times 12 for the mass of the carbon, 6 times 1 for the mass of the hydrogen, 15.994 for the mass of the oxygen. That tells us how many moles of ethanol we have. Then, multiply by the stoichiometry, which is 1 to 2. For every 1 mole of glucose that you react, you get 2 moles of ethanol. And that tells you how many moles of glucose was reacted. And then you multiply by the molar mass of glucose, which is 180 grams, roughly, to give you that you'll get 14.657 grams. Put it 3 significant figures because the question only has 3 significant figures in it. So the final answer is 14.7 grams of glucose is needed to generate 7.5 grams of ethanol according to this stoichiometry. The last part of this question, how many grams of CO2 form when 7.5 grams of ethanol
are produced. So now, again, say 7.5 grams of ethanol, but now how much CO2 is produced? Same number of moles, that's why I scribbled it here, because it's the same number. It gives you the same number of moles of ethanol, but now the stoichiometry is 2 to 2. For every 2 moles of CO2 that appear, 2 moles of ethanol as well will have been produced by this reaction. That will result in multiplied by the molar mass of CO2, 7.164 grams of CO2. You're only allowed to report it to 3 significant figures, so final answer 7.16 grams of CO2 is generated. All these questions, by the way, come from chapter 3 of Brown, our textbook, 10th edition. We'll continue on the next one.